I'm writing, you're writing. What were we talking about in 1.3? We were talking about exponents and just jumping into radicals, roots, okay? So let me jump into some more examples, and these examples should help you along. And again, if you have a calculator that you're using for all of this, I don't restrict you on that, but on the test, on the mid-chapter assessment, I will restrict you, and therefore you need to know how to do it all longhand. All right, so this is 1.3 continued for Algebra 1. I don't know what number was I on, Will. Number 9. This will be our 9th example. Okay, so 9th example, this is going to be simplify. Okay, but when it says simplify, it's also going to say express in expo form. Okay, so we actually are going to have answers in exponential form. And so let's do this one. We have 3 to the 3rd power times 3. So they're not actually looking for you to come up with the answer of 81, which it is. What they're looking for you to do is write it as an exponential form, so 3 to the something, right? So if you have the same bases and you're multiplying them, here's the error. People go 3 times 3 is what? 9. That's the error when we're dealing with what form? Exponential form. So when it's exponential form, we don't mess with the base. The base will stay as 3. What does our exponent turn into then? 4, right? So we have 3 of them here. How many are right here? We just don't write the number. 1. So we have a total of how many? 4 right there. That's your answer right there. The error comes when people, usually they say 3 times 3 is 9, and they'll have 9 to the 3rd or 9 to the 4th. But you don't mess with the base when you're messing with the exponents like that. Okay, so make sure you leave the base as 3 in that case. Okay, let's try this one. 8 to the negative 3 to the 5. Now in this case, they actually are going to be okay having negative exponents. So they actually don't want you to do any reciprocal stuff like we talked about yesterday. They're simply testing exponent to an exponent. When you have an exponent to an exponent, what do you do with your exponents? Do you add or do you multiply? Multiply. Okay? So when you're multiplying the same bases, you add the exponents. When you have an exponent to an exponent, you multiply, and we would just leave it as 8 to the negative 15. Now if they said don't write it with negative exponents, then you would have to reciprocate that. Let's do a quick review. What does the negative on the exponent do? Does it change the base to a negative 8? Never. What does it do? It just reciprocates it, right? So it becomes 1 over 8 to the 15. That's just a review, just to make sure we can just review a little bit of the negative exponents. Okay, let's say we have this one. Give you lots of examples here so you have opportunities for success when you're doing your homework. Okay, we have 12 to the 2nd times 12 to the negative 7th. Go ahead, simplify that one. Leave it, if there's negative exponents, leave it in the negative exponent form. Check with your support team around you, and I'll write another problem up here for us to do. Check with your support team. Let's go to this one for our next one. 7 to the negative 2 divided by 7 to the negative 7. Okay, and then try number 12. So we'll do number 11, number 12, and then we'll go over these together. Okay, just give you a few more seconds here, and if you don't have it, that's fine. Everybody check with your support team around you. That's the expectation. Say, hey, what did you get? Just check with your support team. And it can be just a real quick check. You can even give it a silent check. By the way, who are we missing? I'm going to do attendance real quick. Am I missing Isaiah?
He's not.
No, he was gone on a trip.
Oh, Isaiah was here.
No, you're missing Isaiah. Okay. Okay, so what do we get here? For the first one, same basis multiplied. What do we do with the exponents? Add them. 12 stays the same, and 2 plus the -7 is -5, and we just leave it as such. Okay? The next one is 7 to the -2 divided by 7 to the 9. If you want to rewrite this as this, you can. When you divide the same bases, which we have 7 and 7, what do we do with the exponents? Subtract them, okay? And so we'd actually go 7 to the -2 minus the 9, so you would get 7 to the -11 like that. Okay? And then we leave it as that. You could flip it. We're not going to, but we're just going to leave it as such there. All right, and then let's do one more example along these same lines. And if you have 2 squared times 2 cubed times 3 to the 4th times 5 squared times 5. Again, we're not writing a numerical answer in terms of the answers. 1042. We're going to leave these all in exponential form. Okay, so we look at that. Go ahead, make an attempt at that one. Leaving it in exponential form. The one thing they're testing is, can you combine your 2's and your 3's in terms of the bases? Okay, and the answer is no, not when you're dealing with exponents. So you're going to have to leave those separate. Okay, so we are going to have 2. Let's start with the base of 2. 2 to the what? To the 5th times the 3 doesn't have anything to attach to, right? So it'd just be times 3 to the 4th. And then the 5 would be to the 3rd, because there's an understood 1 there. We just don't write it. So that would be understood. Okay, let's do this. Evaluate. Now, evaluate means we're actually going to get a value out versus leaving it in exponential form. So this is number 14 for us. When we have 4 over 3 to the 3rd power. Okay, so now we have a monomial. I don't think I've used that word before in here, but monomial. A monomial means there's no addition or subtraction in there. So when we have 4 divided by 3, that is a monomial because there's no addition or subtraction in there. Okay? So when you have a monomial to an exponent, what can I do with that exponent? The exponent distributes into the top and to the bottom. That's only because there's no addition or subtraction. Later we'll see an addition or subtraction at some point, and you can't distribute in. So what this is 4 to the 3rd over 3 to the 3rd. We talked about this. Should we start memorizing 4 to the 3rd, 3 to the 3rd, 5 to the 3rd? Yeah, you should start having those memorized. If you need to do them longhand, that's fine. It just takes a little bit of time. All right, 4 to the 3rd. What do we end up with for that? 64, right? So we get 64 over, what's 3 to the 3rd? 27. And then that is where we can leave it. Is there anything in common? There is not on that 64 and 27, nothing to reduce it. Do you need to turn it into a mixed fraction? No, do not need to turn it into a mixed fraction, so just leave it as such. Okay, let's go with number 15 over here. Evaluate this one as well. And let's go with the cube root of a negative. Let's go with -8. Now, since this is a cube root, we talked yesterday about square roots of negatives. Remember what the cube root, the square root, meaning this index, this is called the index. What this is asking is, what multiplied by itself 3 times gives you the -8, because it's a cube root. If it was a square root of something, like let's say -16, that would be asking what multiplied by itself gives you a -16. So I'll come back to that in a second. So let's think about this. what times what, three things, gives you a negative 8? Yeah, Michaela. Yeah, negative 2, you bet. So if you think about that, a negative times a negative times a negative, there's 3 negatives, that will stay a negative, and then 2 times 2 times 2 is 8, so that checks for us. The issue would lie here if I said what times what, because this is a square root, gives you negative 16. Well, you would say a negative 4 times 4, are those two the exact same value? No. So what if you said 4 times a negative 4? Not the same value. So in our real number system, do either of those work to actually be the same number to give me negative 16? No. You would either have to say a negative 4 times a negative 4, but what's a negative 4 times a negative 4? Positive 16, which we're looking for a negative 16. So that doesn't work. These don't work. So therefore, this would fall in the category of an imaginary number. But I don't know if I referenced that with you. I don't like, and we'll eventually deal with those in math. Imaginary numbers are actually real numbers. They're numbers that do work, just in a different type of system. But for our purposes, we would say for this one, there is no real number. Okay, so no real number on something like that. This, there is a real number because it's the cube root, and you can have 3 negatives. Giving you a negative is no problem. So that's where we get that. Okay, let's do another one here, number 16. And what if you have the cube root of 27 over 64? So in this case, when you have the cube root of 27 over 64, what you're asking is what 3 things? Now, since this is division right here, I can work with the top and I can work with the bottom individually. You don't need to, but you could write this as the cube root of 7 over the cube root of 64. You don't have to do that, but you could. And so then we just ask, what is the cube root of 27? And hopefully these are things that you start to pick up on. The cube root of 27 is 3, and the cube root of 64 is 4. And then that would be your value right there, 3 over 4. And then we would leave it at that. Don't need to turn it into any type of decimal. Okay. Yeah, Nicole.
Would you write the 3 over that answer 3/4, or would you just leave it as 3/4 in the answer?
Write the 3 over the 3/4?
Would you still write cubed, 3/4 cubed as the answer?
Oh, great question. Thank you for bringing that up. So once you take the square root or the cube root, the radical disappears. So like this, because this often happens. But, well, let's not try to do that one. Let's do. So what Nicole is asking is this: if I have the square root of 25, remember the square root is asking what times what gives you 25. So hopefully most of us, right? What times what gives us 25? 5. So our answer is 5. And that's it. If you said your answer, what Nicole is asking is, do I leave it as the square root of 5? The issue is that the square root of 5, what you would be stating then is if you went to here, the square root of 5 is saying the square root of 5 times the square root of 5 is equal to the square root of 25, and that's not true because the square root of 5 times the square root of 5 is actually just equal to 5, not 25.
I meant if you wrote it squared, 5 squared, would that be your answer?
5 squared? No, because the square root of 25 doesn't equal 5 squared. Because the square root of 25 is 5, 5 squared is 25. So those don't equal. Okay, thanks for clarifying your question. So once you take the square root or once you take the cube root, you eliminate the radical and you eliminate the exponent in these cases. There will be a case down the road, like if we say the square root of 5 to the 4th power, then we'll talk about that. That would turn into 5 squared. You still have an exponent on that. But we don't hit any of those right now. We leave those. Okay? So let's stop there. Is that where we want to stop? Yes, yeah, you guys want to stop there, I'm sure. We have 1 through 43 as. Okay, we're going to stop there. Let's utilize our time. When is 1-3 going to be due? Monday. What else is also due? 1.2. So 1.3, 1.2 due on Monday. Use the remainder of the time. If you're all done with your homework from 1-3, that's awesome. Take a deep breath. You can help people around you, or you can look ahead to 1.4. But don't be a distraction. Okay, so Monday, 1, 2, and 1, 3, utilize the next 15 minutes, 14 minutes to work on homework. And if you're all done, find something productive to do.